Okay. So could you see the section 6.6 inverse trigonometric functions? Could you see like this kind of the slides? Please write yes on your chatting board and turn off your audio, please. Okay, good. Okay, today I want to talk about section 6.6, the inverse trigonometric functions. It's like outline. I want to talk about definitions and graphs of the inverse trigonometric functions. Second one, I want to talk about the properties of the inverse trigonometric functions. Third one, the derivative of the inverse trig functions. Last one, how can you find integrals for the inverse trigonometric functions? I want to talk about these four kind of things today. Please turn off your audio, please turn off your audio, please. The first one, the definitions and graphs of inverse trigonometric functions. So this is y equals sine x is like a blue one. It's blue one. This is equation. Does the inverse function exist? The inverse sine function exists or not? Could you write your answer on the chatting board, please? Yes or no? No. Okay. No. No. Okay. Answer is like this. You can draw horizontal line intersects the graph of y equals sine x more than once. Could you see? This red one is horizontal line. We have 1, 2, 3, 4 more. The more than 2, the more than 1, the more than 1. So this case is not one-to-one by using horizontal line test, not one-to-one. The inverse function does not exist. How can you find the inverse function of f of x equals sine of x? Yeah, the Eric said, the restrict the graph. You're right. So we have the infinity many the restriction of the graph. One possibility is cut here. Is right. Only use this graph. Is one-to-one. Or cut like this. Use second one, third one, and so on. So we have the infinity many possibility. I will choose one. The typical case, only first case, from negative pi over 2 and pi over 2. Can they restrict from minus pi over 2 to pi over 2? This is one idea. So restrict the domain. X is between negative pi over 2 and pi over 2. This is the idea. So here, this is like a sine function. Domain is the negative pi over 2 to pi over 2. The range is minus 1 and 1. That's right? So here, the minus 1 and 1. The minus 1 and 1, like range. How can you find inverse function? I want to use geometric method. Reflect the graph of f of x equals sine x about y equals x. So what does it mean? You can draw. Why do you choose this domain? So we have infinity many possibility of domain. X is between negative pi over 2 and the pi over 2 because you can make a one-to-one function. This is the reason. We are going back to previous example. You can only restrict domain from here to here, like this. This one is one-to-one function, but you can connect more, not one-to-one. This is the reason. You can choose this one. Why do you choose negative pi over 2? We have infinity many possibilities. The another choice is pi over 2 and 3 pi over 2, or 3 pi over 2 and 5 pi over 2. It's infinity many, but I want to choose like a small number. It's sometimes better. This is the reason. You can choose like minus pi over 2 and the pi over 2. here, so like this. Reflect the graph of f of x equals sine of x about y equals x. So what's that? You can draw y equals x. This dotted line. You can draw y equals x. You have to reflect this blue one, sine function. Blue is the sine function about y equals x. What happens? Graph is like this. Graph is like this. This is like inverse sine. This is like a whole idea. This red one is inverse function. What happens? This pi over 2 is going to here. Pi over 2. This one is going to negative pi over 2. The range one is going to here. The minus one is going to here. This is exactly inverse sine function. This is like a whole idea. Like this is the right one. The inverse of f of x is, I'm going to use one notation, inverse sine of x or arc sine of x. Just a notation of inverse of sine function. What's the domain of inverse function? Minus 1 to 1. Range is minus pi over 2 and pi over 2. What does it mean? This is like y equals sine of x. What happens? The range of function f is going to domain of inverse function. Domain of f is going to range of inverse function. This is like exact meaning of inverse function. I'm going to use cancellation equation. F of inverse of f of x equals x. You can replace. The function f is sine. Inverse of f is inverse sine. We have sine of inverse sine of x is itself x. What does it mean? Sine and inverse sine are cancelled. In the domain of inverse function, x is between minus 1 and 1. The inverse of f of x equals x is similar. The inverse sine of x equal to x for all x in the domain of sine, then pi over 2 and pi over 2. This is like idea for finding inverse of sine. What's like a cosine function? Similar. Cosine function is not 1 to 1. You have to restrict the domain. How can you restrict the domain? We have infinitely many possibilities. 0 to pi, pi to 2 pi, 2 pi to 3 pi, and so on. What's like the best way? You can choose small number. The 0 to pi is the best choice. I can choose this kind of things. Here we have it. The domain is from 0 to pi. Range is minus 1 and 1. How can you find? Reflect the graph of f of x equals cosine x about y equals x. Same idea. Like a geometric method for finding inverse function. How can you do that? You can draw y equals x. Same. You can draw y equals x. You have to reflect this blue graph, blue one about dotted line y equals x. So what's that? This blue one is going to here. This remaining blue one is going to here. So like this, right? Connected like this way. So what's that? This is 1. This value is minus 1. The range of function f is going to domain of inverse. Domain of f is going to range of inverse function. This is like pi, this is like 0. This is the whole idea for sketching the graph, the inverse cosine function. So we have the like this. Inverse of f of x is inverse cosine of x, just notation, or arc cosine of x. What's the domain? What's the domain of inverse function? Here, exactly, range of f is going to domain of inverse. What's like range? Range is domain of f is going to range of inverse. This is like idea. So similar, we have cancellation equations. Cosine of inverse cosine of x equal to x for all x in the domain of inverse function minus 1 and 1. Inverse of f of x equals x, cosine inverse of cosine of x equal to x for all x in the domain of cosine function. We have similar result like this. That's right. So one more. This is tangent function. Tangent function. So how can you find inverse function? Same. The restrict domain from the negative pi to and the pi to, because we can make one-to-one function. Domain is minus pi to and pi to. Range is minus infinity to infinity. How can you find graph of f of x? Same. You have to draw dotted line y equals x here. So could you turn off your audio, please? So could you turn off your audio? You can make a mute, MUT, the mute, the bottom on the your Zoom. So please turn off your audio, turn off your video. Thank you. So you have to reflect this blue one about dotted line. What is it like graph? Graph is this one, like this. This one is like this. We have this kind of graphics. Oh yeah, the range infinities, you cannot plot. Yeah, infinity is impossible because the x value approaches 5 to tangent function is going to positive infinity. Only use asymptote, the vertical asymptote. We don't have like don't include minus infinity. Don't include infinity. Always exclude. Yeah, infinity is like not a number. So this vertical asymptotes are going to horizontal asymptote here, the next one. This is pi over 2. This is also the negative pi over 2. This is whole idea. Oh, yeah. So this section is section 6.6, the inverse trigonometric function. Yeah. The one more. So you can find my lecture note on Canvas. I already uploaded this lecture note on Canvas. You can go into module, click the week 2. You can find same kind of the lecture note, the section 6.6. Here, we have the graph of the inverse function is like this. What happens? This vertical asymptote is going to horizontal asymptote. The left one is going to bottom, like this. This red one is inverse sine. So inverse of f of x is, you can use notation, inverse tangent of x or arc tangent of x. This is the idea. What's the domain? The minus infinity to infinity. So range is going to here. What's the range? This one. The domain of f is going to range of inverse function. So what's like a limit? Inverse tangent of x as x approaches minus infinity. Could you write your answer on this question? So what is the answer? What's that? Do you know what is the answer? X value approaches minus infinity. What happens? Inverse tangent of x. Okay. So could you write answer? So what is the answer? Okay, I'm waiting. Okay. Some guy, one student said 0, the negative pi over 2. So what do you think? Can you write your answer on the chatting board? Don't worry, just write. Okay. 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 It's good. So what happens? X value approaches minus infinity. Here, X value approaches minus infinity. So what happens? Corresponding function value inverse tangent. The inverse tangent approaches to this dotted line. Y value is negative pi over 2. This is like idea. What is answer? The same. Could you write your answer on the chatting board, please? What's the limit inverse tangent of x as x value approaches positive infinity? Okay, good. So your answers right. Yes, pi over 2. Similar. X value approaches positive infinity here. X value approaches positive infinity. What is the corresponding f of x? Corresponding function value approach to this dotted line. So we have pi over 2. This is like idea. What's the f of inverse of f of x? Is also x. We can use cancellation equation. You can apply cancellation equation to inverse tangent and tangent function. So we have tangent of inverse tangent of x equal to x because cancelled for all x in domain of inverse function like minus infinity to infinity. The next one is inverse of f of x equal to x, same. Inverse tangent of x equal to x for all x in the domain of tangent function. The near pi over 2 and pi over 2. So for solving this problem. Please turn off your audio and video. Please turn off your audio, your video. Please. Substitute the turn off the like your audios, please. Turn off your audio, please. Let me see. The next one, the remaining inverse trig function, I don't talk about more. We can use similar methods for finding inverse sine, inverse cosine, inverse tangent. We have similar result. Y equals inverse cosecant x is, this is like a relation. Cosecant y equal to x, like y is in this domain. The y equals inverse secant of x, you can use definition. Secant of y equals x, y is between these two intervals. Y equals inverse cotangent of x, the cotangent y equal to x, y is between 0 and pi. This is like a whole idea for solving this kind of problems. We can evaluate this one. So, how can solve? Do you have any idea for solving this problem? Yeah. You don't need to draw the graph of inverse cosecant, inverse secant, inverse cotangent. You don't need it. But it's sufficient for knowing like sine, cosine, tangent. Another one, inverse sine, inverse cosine, inverse tangent. So, but if you try to solve some kind of a problem, I can explain that later. So sometimes you need to use domain. This is like key. You need to use domain for solving some problems in your web assign, your quiz, only relation. Do you remember cancellation equation? You can use a cancellation equation, only use domain. Very sufficient. So you don't need to draw the graph. Yeah, you have to memorize this kind of domain and range. Yes, you can memorize these kind of things. Sine, cosine, tangent, cosecant, secant, cotangent. So you need to know this kind of domains. Yep. So please turn off your audio, please. Maybe I got some noise in here. Similarly, the other students get same noise. Please turn off your audio. Just only mute in your audio, the part in your Zoom. So you can use it answer is minus pi over 2. It's right, I think. You can check it. You can only step by step is better. You can think about it here. X value approaches 5 from the left. X value approaches 5 from the left. What happens? The inside one first, 5 minus x. You can plug 5 into x. 5 minus x approaches 0. Let me see. 0 from the left, 0 from the right. How can you know that? Depending on one side limit. Here is 5. X value approaches 5 from the left. I can choose one test number 4.9. You plug into this x. 5 minus 4.9 is positive 0.1. What does it mean? 0 from the right, like a positive number. The next one is ln function. What happens to ln function? What is your answer? Could you write your answer of this one? The ln of 5 minus x approach to the 1 to set the minus infinity, the 1, how about the other students? The minus infinity. Oh yeah, y is plus. Yeah, I just said it before. You can use x value approaches 5 from the left. So what does it mean? X value approaches 5 from the left. You can choose any number less than 5. Plug into here. 5 minus 4.9 is positive number. We can use positive sign. This is the reason. Okay. Oh, really be careful. This is one good comment. Let me see. What's error number 1? What's error number 1? Yes, error 1 is 0. What is error number 0? Undefined. What does it mean? Here, the inside one, 5 minus x approaches 0. You can sketch the graph ln function. Was it like ln function? The ln of x is graph is like this. Here, the ln of x is graph is this one. This is ln of x. Inside one approach 0. Inside one is exactly root of x. Inside one approach to 0. What's the corresponding ln function? Corresponding ln function approach is, yes, negative infinity. We have negative infinity. So like this. The next step is last one, arctangent. What's like arctangent of ln of 5 minus x. So we can draw graph of arctangent. The graph of arctangent is like this. You can draw horizontal asymptote pi of 2. You can draw negative pi of 2. The arctangent is graph is like this. This is arctangent. What happens inside one ln 5 minus x approach to minus infinity. So what does it mean? The inside one is root of x. The inside one approach to minus infinity. The corresponding arctangent approach to dotted line negative pi of 2. So answer is approach to negative pi of 2. What's the final answer? Final answer is negative pi of 2. This is the whole idea for solving this problem. Right? This is the same. Could you turn off your audio, please? Oh, why is it negative? So this meaning negative infinity you said? The negative infinity is here. The x value, 5 minus x approaches 0 from the right. It doesn't matter any side. From the right, the corresponding graph is going down. This is the reason we can use minus infinity. That's good? Just plug some number into, I don't know, 5 minus x. This is like, it's not good. It's not good because only use graph is better. We can plug a number. You cannot find the infinity value. So you said like this, you can plug 5 into x, and over 5 minus 5 is undefined. The approach to minus infinity, the exactly arctangent of negative infinity is minus 5, 2. This is like a one idea, but not exact method, but you can use it. It's possible. Oh, from the right. Okay. So you can change the original one. X value approaches 5 from the right. What happens? This is another question. You can change it. Probably like this. Limit X value approaches 5 from the right. 5 from the right. The arctangent of ln of 5 minus x. What is your answer? What do you think? Infinity does not exist. So here, x value approaches 5 from the right here. The x value approaches 5 from the right. What does it mean? The 5 minus x is negative number. ln of negative number is undefined. Undefined. For ln function does not exist. Arctangent does not exist. Answer is does not exist in this case. So we cannot define this kind of things. The greater than 5 is the impossible for solving this problem. Only less than 5 because ln function is well defined on positive numbers. On the positive number. ln of a negative number undefined. This is like a reason. So we cannot use it. So it's good. Do you have more question about this question? Do you have more question? Always write your question on the chatting board. I do my best to answer your question. Okay, next one. So this is like answer, so like this. Here, exact value of inverse sine of sine pi over 4, inverse sine of sine 5 pi over 4. First one, we can use this one. Inverse sine of x equals x for all x in negative pi over 2 and pi over 2. Could you turn off your audio, please? You can check your audio is like off or on. Could you check, please? Here, let me see. Was it like the next problem? This one. What's your answer? Inverse sine of pi over 4. What is your answer? Pi over 4 is right? Okay, thank you. Pi over 4? Pi over 4? Okay, thank you. The answer is pi over 4. So what do you think? Is it right? Yes. You can cancel. Here, was it like a pi over 4? The pi over 4 is between minus pi over 2 and the pi over 2. Like this. So yes, you can cancel. Answer is pi over 4. Yes, we have it. Because pi over 4 is in the domain. So what is the answer? So 5 pi over 4 is right? 5 pi over 4? What do you think? The pi over 4 again, the minus pi over 4, the pi over 4, what do you think? the pi over 4. So let me see. This is wrong. So you cannot cancel the because 5 pi over 4 is not in the domain. Yes, this is one idea. You can change it. We think about sine 5 pi over 4. How can you calculate sine 5 over 4 first? So what's that? Here, I can draw rectangular coordinates. What's like a 5 pi over 4? So this positive x-axis is angle 0. The y-axis is pi over 2. The negative x-axis is 5 pi over 4. So this one is, negative pi, positive pi. This is 3 pi over 2. This is also 2 pi. We have this angle. The 5 pi over 4 is between pi and 3 pi over 2. We have here. This like angle. So we have it, this one. So this angle is exactly 5 pi over 4. So what happens? What kind of sine function? The sine function is the first quadrant positive, second quadrant positive, third quadrant negative, first quadrant negative. So what does it mean? Sine function is in here, we have same value. What's like this angle? This angle is exactly negative pi over 4. Negative pi over 4. So what does it mean? Sine 5 pi over 4 is exactly same to sine of negative pi over 4. You can change it. So we have this answer. Inverse sine of sine 5 pi over 4.
Calc 2.
Same to what? Inverse sine of sine 5 pi over 4 is sine of negative pi over 4. So minus pi over 4 is in the domain. Yes, you can cancel this kind of things. Final answer is negative pi over 4. Just like a whole idea for solving this kind of problems like this. We have it. The next thing. Oh yeah, you cannot change domain. You're right. So don't change domain. Domain is fixed. Always minus pi over 2 and the pi over 2 from the sine function. What's the cosine function? 0 to pi. The 0 to pi. What's the tangent function? The tangent function has the negative pi over 2 and pi over 2. So we have this kind of domain. Don't change domain. Don't change domain. Find the exact value of sine arctangent of 3 and simplify cosine of inverse sine of x. X is positive or equal to 0. So let me see. How can you solve this kind of problems? You can follow the step-by-step is better. So here, we don't know the arctangent of 3. So you can write the arctangent. Sorry, I just need to change a little bit. So just wait a minute. Okay, I'm going back to the slides. Right here. Yep. So from here, we have this one. The arctangent of 3, we don't know. I can write unknown value theta, like this. So do you know like a definition or relation between inverse function and the function f? So here, the inverse of x equal to y, the equivalent to the x equal to f of y. This is like a relation between the function f and the inverse function. So same. You can use this one. Arctangent of 3 equals theta. You can change it to the arctangent is exactly log of inverse. Change to the tangent function. So we have 3 equals tangent of theta. The 3 is 3 of 1. You can draw right triangle. So like this. I can use definition of tangent. Definition of tangent is opposite over adjacent. 3 over 1. You can find the hypotenuse. We don't know. I can derive like R. I can find, you can use Pythagorean theorem. 1 square plus the 3 square equals R square. Exactly. 10 equals R square. Take square root. R equals square root of 10. So R is square root of 10. So we have it. Next, you can plug here. What's like the arctangent of 3? Theta. You plug into here. So what's that? Sine of arctangent of 3 is sine of theta. You can find sine of theta by using right triangle again. What's like sine theta? Exactly the opposite over hypotenuse. We have 3 over square root of 10. That's it. This is final answer for solving this problem. Like this. The next one. How can solve this problem? Similar. Inverse sine of x is right theta. So next, same thing. You can use relation between inverse function and function f. So we have x equals sine of theta. So this is x of 1. Same. You can draw right triangle, theta like this. The beginning of the last, what's the beginning of the last? What does it mean? Which one? Could you write the more like accurate? I can explain to you later. First, I want to finish this problem. The next, I want to answer your question. Oh, how can you know tangent theta equals 3? Just only here. The arctangent of 3 is like theta. You can use definition. Arctangent 3 is exactly inverse function of 3 equals theta. So what's like a relation of f and the inverse function? Change it. 3 equals f of theta. The function f is tangent. This is the reason. You can use this kind of things. It's good? The next, going back to inverse sine function again, similar. Inverse sine of x is, we don't know angle theta like this. You have to use same relation. So this is x of 1 equals sine theta. So we have here x over 1 is sine theta. Find adjacent by using Pythagorean theorem. What's that? The y square plus x square equals 1 square. Subtract x square from both sides. The y square equals 1 minus x square. The next, take square root. Y is the positive and the negative one, but don't use the negative one because y is length. The length is always a positive one. The square root of 1 minus x square. This is the square root of 1 minus x square. So we are going back to exact problem. Cosine of inverse sine of x. How can you do that? You can change the angle theta. Inverse sine of x is theta. So like this. What's cosine theta? Cosine theta is adjacent over hypotenuse. Adjacent is square root of 1 minus x squared over 1. Exactly, square root of 1 minus x squared. That's it. This is the whole idea for solving the second problem. So like this. This one. So next, how can you find derivative of inverse trigonometric functions? Here, y equals inverse sine of x equals sine of y, is right? You can use the relation between inverse function and function f. What does it mean? The next one, y equals the inverse of x equivalent to the x equals f of y. It's like idea. So we have it. So we have this kind of things. The next tip, you can differentiate x equals sine of y with respect to x. So what happens? Take derivative. Do you know what is sine of y prime? Do you know that? What is sine of y prime? Could you write your answer? What is sine of y prime? The cosine y is right. Could you write more? Cosine of y, cosine of y, cosine of y, cosine of y, cosine of y. Please answer your question on the chatting board, please. Cosine of y. Oh yeah, another guy said cosine of y times y prime. You're right. You can use chain rule here. So we have f of g of x prime f prime of g of x times g prime of x. What's it like g of x? G of x is log of y. Yes, you can use sine prime is cosine of y times y prime. You can use chain rule. So like this, you can divide the both sides by cosine of y. The next, you can change cosine of y to the x variable. How can you do that? I'm going to use this one. Sine square plus cosine square equals 1. Cosine square of y equals 1 minus sine square. Take square root, the square root of 1 minus sine square y, the negative square root of 1 minus sine square of y. We have two possible answers. You can check which one. Positive one or negative one? What do you think? Positive one or negative one? What do you think? Which one? Positive one, negative one? Positive one? The positive root 1 minus sine square, one negative root 1 minus sine square. Positive, 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 is right? Positive. So why? Why do we have a positive? Why not negative? Why? Do you know the reason? Why do you choose a positive one? Domain is not 0 to 5, 2. The negative 5, 10, 5, 2. So here, so what's that? We have this one. What is it like a domain of inverse function? X is between minus 1 and 1. This is domain. What is range? Range is negative 5, 2 and pi over 2. This is like range of inverse sign. You can plug any number between the negative 5, 2 and 5, 2 into y. The cosine function is positive or not. You can draw rectangular coordinates here. This portion is negative 5, 2, 0, 5, 2. Exactly the first quadrant or first quadrant. What's the cosine function? The cosine function is positive in first quadrant, negative in second quadrant, negative in third quadrant, positive in first quadrant. The fourth always positive. This is reason. You cannot decide negative. This is like the exact reason. You got it? So you cannot use either, only positive. This is like reason. We use positive one. Here, only positive one, because y is between the negative 5, 2 and 5, 2. The cosine y is positive y equal to 0. This is the reason. Only use positive one. Here, the y prime equals 1 over cosine of y. We are going back to this one again. You can change it. What's it like a cosine of y? The cosine of y is here. This one, you plug. You can change back. What is sine of y? What is sine of y? Do you know sine of y? What is sine of y? Is x, is it right? X? Is x? Yeah, this is x. X? Yeah, from the original one. Sine of y is exactly x. You plug back into here, we have 1 over square root of 1 minus x squared. So we have one good result. What's it like y prime? Y prime is inverse sine of x prime. So we have one good result. Inverse sine of x prime is exactly 1 over square root of 1 minus x squared. We have one good result, like this. We have one good table. The what's the inverse sine of x prime? The 1 over square root of 1 minus x squared. Oh, cosine y is like undefined, you said. So wait a minute, we are going back to here. Oh yeah. You said here, y prime is 1 over cosine of y. The what happens to y, you said? Oh yeah. This case is, you plug 0 into here. You said this is like undefined. Undefined. So in this case, you don't think about endpoint because was it like the sine function, inverse sine function? Inverse sine function is exactly the minus 1 to 1. The graph is like this, is right? Here, this is like 1. This is minus 1. So we don't have any derivative at the end point, 1 and the minus 1. What does it mean? In this case, you have to exclude. Cosine of y is 0. You can exclude. Always find the minus infinity, positive infinity. It's like a good comment. Always don't think about the cosine y equal to 0 because you always exclude endpoint from the domain. So how can you find the derivative? This kind of things. Always use here. Was it like derivative things? Always y value is what? Exclude endpoint. Exclude endpoint. Exclude endpoint. So cosine of y is non-zero. Don't worry about for finding y prime. This is the reason. Yeah. Does it make sense? So cosine of y equal to 0, you're right, undefined, but you can define derivative, always exclude endpoint for finding the derivative, the endpoint. Here, table of derivatives of inverse trigonometric function. What's the inverse sine of x prime? As I said before, 1 over square root of 1 minus x squared. What's the inverse cosine of x prime? You can use similar method for finding inverse sine of x prime. We have this result. You're right. Negative 1 over square root of 1 minus x squared. What's the inverse tangent of x prime? 1 over 1 plus x squared. The inverse cotangent of x prime is the negative 1 over 1 plus x squared, right? So inverse secant x is 1 over x times square root of x squared minus 1. Inverse cosecant x prime is the minus 1 over x times square root of x squared minus 1. So you have to memorize this is 6 rules. You have to memorize these 6 rules. To memorize the derivative rules. You can memorize this kind of things. Next week, we think about this problem. F of x equals arctangent of sine of x. Find derivative. F prime of x is arctangent of sine of x prime. What is answer? Here, the arctangent is like function f. Sine of x is like g of x. What does it mean? You can use chain rule. F of g of x prime. So we have outer function prime of inner function times inner function prime. You can use it. What is arctangent prime, outer function prime? We have here the arctangent of x is the same as the inverse tangent, 1 over 1 plus x squared. Only plug sine of x into here, x. So we have 1 over 1 plus sine of x squared times inner function sine of x prime. So we have sine x prime is cosine. You can keep 1 plus sine square of x. Right? That's it. This is the final answer for solving this problem. Like this. The next one. How can you find y prime? Oh, there was like a domain of function of sine of x, you said. But here, this is like a good question. Here, so in this case, when you think about inverse function first, inverse function, what is domain of arctangent? What is domain of arctangent? Domain of arctangent is all real number. The sine of x is all real number. What does it mean? X is all real number. You don't need to restrict the domain of a sine function in this problem because we don't define inverse sine, just arctangent, inverse tangent. So domain is all real number. Don't worry about this kind of problem. So here, the second problem, your question is like the second one. Arcsine, you said? Arcsine? The arcsine of root x was like a domain of arcsine. Domain of arcsine is inside one is between minus 1 and 1. So root x is between minus 1 and 1. The root x is like negative impossible. What's the domain? X is between 0 and 1. In this case, what's the domain? Like this. Don't include 0 because plug 0 into here undefined 0 to 1. It's like a domain of this question. Yeah, domain of second. It's good. Here, how can you find dy with dx? So exactly 1 over arcsine of root x prime. The arcsine of root x. So what's that? I'm going to change this one to the like this. Arcsine of root x to the power minus 1. Power minus 1. You can use power rule first. Do you know this one? So we have g of x to the power n is given. Find the derivative. What's that? N times inner function g of x to the power n minus 1 times g prime of x. This is like idea. So this is same to here. The minus 1 is like a power down. Minus 1 times the inner function to the minus 1 minus 1. So like this. This is arc sine root x times inner function arc sine of root x prime. So what's that? Minus 1 times arc sine root x to the negative 2 times. What's arc sine of root x? You can use chain rule again. What's like arc sine prime here? You can use arc sine of x. The prime is 1 over square root of 1 minus x squared. You can use it. Only plug inner function root x into x. So we have 1 over the square root of 1 minus square root of x squared times inner function prime. So like this. So simplify. My solution going to top, change to the positive exponent, the arc sine of root x squared times 1 over the root x squared is only x, square root of 1 minus x times root x prime is 1 over 2 root x. So what's that? You can combine. Top is minus 1. You can combine this one. We have 2 times. What is root 1 minus x times root x? You have to split like this or combine. Either one is fine. Either one is fine. I want to combine. This is square root of 1 minus x times x, square root of x minus x squared. We have square root of x minus x squared times arc sine of root x squared. That's good. That's right. So like this, we have this answer. What's like integral of inverse trig functions? Do you know the relation between the inverse, the like f prime and the f? Do you have this relation? Do you know this kind of things? The one example is, what is x squared prime? What is x squared prime? Do you know x squared prime? Oh yeah, thank you. Answer is what? Yeah, it's right. 2x is good. Yes, thanks. 2x. What is integral 2x dx? Yeah, x squared, you're right. So like this, what does it mean? This is my point. Function f of x is given. Take derivative, you can write f prime of x. So like this. That's good. So another one, you can only use capital F prime of x is like little f of x is given. Capital F is we call antiderivative. Was like integral little f of x dx. Exactly capital F of x plus c. It's like whole idea. I'm going to use this method for finding the integrals for inverse trigonometric functions. So we have here. We know that this one, inverse sine of x prime is 1 over square root of 1 minus x squared. Is right? We have it. So we can use this rule. So what is the answer? So we have integral 1 over square root of 1 minus x squared dx is inverse sine of x plus c. So we have it like this. Similarly, the tangent, inverse tangent of x prime. So we have 1 over 1 plus x squared. What is integral 1 over 1 plus x squared dx? The like antiderivative inverse tangent of x plus c. We have two important integral rules you have to memorize. This one, so like this. The next problem. You know, how can you solve this problem? Here. So we don't have it. This is like a squared is constant. We change 1. How can change it? This one to the like this. Integral 1 over the factor out a square. Factor out a square 1 plus x square over a square dx form. Change it like this. Same to like this. Only take out 1 over a squared. Integral 1 over 1 plus x over a square dx. The next thing, I'm going to use u substitution. U equals this inner function x of a. What is du? Do you know du? Du is x of a prime dx. So like this. So my question, what is x of a prime? What's that? Do you know what is x of a prime? Could you write your answer on the chatting board? What is x of a prime? The 1 over a? The 1 over a? Is it right? 1 over a? What do you think? The 1 over a? The 1 over a? Is it 1 over a? Yeah, this is 1 over a because a is constant, only x prime. X prime is 1. 1 times 1 over a is 1 over a. So we have the du is 1 over a dx. So one more. We don't have like a in here. Only multiply by a. This is a du equals dx. Only replace. Same to what? The 1 over a squared. You have to keep integral 1 over 1 plus u squared. The dx is a times du. So what happens? 1a is crossed out. So we have 1 over a integral 1 over 1 plus u squared du. This is 1 over a. What's integral 1 over 1 plus u squared? You can use formula here, inverse the tangent of u. Can change it back. This u value is a of x. You have to change it back. The final answer is 1 over a inverse tangent of x of a plus c. We have this new formula, like this. It's a new formula. The one example. So do you know what's the answer of this equation? What's integral 1 over 9 plus x squared dx? What is the answer? So what is the answer of this equation? So could you write your answer on the chatting board? This is change like this. Change like this. This form is same to this one. Was a is 3. As 3, you can plug 3 into a. What's the final answer? 1/3 inverse tangent of x over 3 plus c. That's it. This is the answer. The 1/3 inverse tangent of x over 3 plus c. This is the final answer of this question. Right? Always use the general formula. So remind. 1 integral 1 over root 1 minus x squared dx is inverse sine of x plus c. Integral 1 over 1 plus x squared dx is inverse tangent of x plus c. Integral 1 over the square root of a squared minus x squared dx is inverse sine of x over a plus c. Integral 1 over a squared plus x squared dx is 1 over a inverse tangent of x over a plus c. Just like whole idea. But let me see. This is a problem. How can you solve this problem? How can you start? Which method do you want to use for solving this problem? What do you like step 1? What do you think? What is step 1 for solving this problem? What do you think? Could you write your method on the chatting board, please? What kind of method do you want to use? You're right, arc sine, but not now, because if I use arc sine, a squared is good, but 4. This is just x, right? Just x. The arc sine x of just 3, answer is like this. Like this. So you can use U substitution. The U substitution. How can you use substitution? You can change this one to the integral 1 over the square root of 9 minus what's like a 4x squared. You can change it 2x whole squared dx. Change it like this. The next what is u? U equals inside 1 2x. The tu is 2x prime dx. The tu is 2 dx divided by 2. So we have 1 over 2 du equals dx. You can change it. Integral 1 over the square root of the 3 is change 3 square. The 2x inside one is the same to u. What's like dx? Dx is here 1 over 2 du. 1 over 2 du. So what happens? Take out 1 over 2 integral 1 over the square root of 3 square minus u square tu. So let me see. Really be careful. So what is the difference between inverse sine and the inverse tangent? Inverse tangent has 1 over a. What's the coefficient inverse of sine? Just 1. Don't use a. This is key. You have to only keep 1 over 2. Keep 1 over 2. So what's that? Only plug 3 into a. 3 into a. What does it mean? The inverse sine of u over 3 plus c. You can change back. So u value is 2x. So we have 1 over 2 inverse sine of 2x over 3 plus c. This is a whole idea for solving this problem. So like this. So on. Next, last one. How can you solve this problem? What's your first step? So which method do you want to use for solving this problem? Could you write your answer? U sub, can the set cosine x equal to u sub? Yeah, this is idea. You're right. The u equals cosine of x. The tu is cosine x prime dx. So we have du equals cosine x prime is negative sine x dx. So like this. Integrand doesn't have minus 1. You can multiply the both sides by minus 1. So we have negative du equals sine x dx. So we have it. So how can change? 이거. The sine x dx is here. Negative du. Just negative du. The cosine x is u. We have 1 plus u square. The one more. You have to change 0 and 5 to. So what's that? You can use relation between u and x. Cosine of x is g of x. You plug 0 into here, exactly g of 0. Plug 5 2 into here, g of 5 2. You can change lower limit, upper limit. You can take out negative 1. Take out negative 1. So we have negative 이네거. Was it like g of 0? The g of 0 is cosine of 0. Is right? You can plug 0 into x. Do you know what is cosine of 0? Could you write your answer? Okay. The more? Could you write more? Okay. Yep. Good. Answer is 1. You're right. So we have 1. You can plug 5 2 into here. What's g of 5 2? G of 5 2 is cosine of 5 2. What is the answer? Okay. Okay. Good. Answer is 0. Yes. 0. The 1 over 1 plus u square du. You can keep negative. 이네걸 1 over 1 plus u square is exactly inverse tangent of u from 1 to 0. So you can plug 0 first, negative inverse tangent of 0 minus negative inverse tangent of 1. You can calculate. This is same to what? Inverse minus inverse tangent of 0 plus inverse tangent of 1. What's the inverse tangent of 0? Do you know how can you find inverse tangent of 0? You can use this method. Inverse tangent of 0 is we don't know angle theta. You can use the definition. The 0 equals tangent of theta by using the relation between inverse function and the original function. So which angle has a tangent 0? Angle theta equals exactly 0. So this is going to 0. The next one. What is inverse tangent of 1? Could you run your answer? What is inverse tangent of 1? You know? Yeah. Could you write more? How about the other students? Yeah. This angle is like a theta. You can use definition. Inverse tangent of 1 equals angle theta. You can find this exact value. We don't know theta. You can use definition of inverse tangent. Inverse tangent of 1 equal to theta, same to 1 equal tangent theta. So like this. Which angle has tangent function 1? So angle theta is exactly pi over 4. This is the reason we have pi over 4. Answer is pi over 4. This is whole idea for solving this problem. It's good. This is all for today's lecture. If you have any question, please write on the chatting board. I will answer your question now. If you don't have any more question, you can leave this live session. Thank you for attending today's class. I really appreciate. Okay, you're welcome. Yeah, have a good night too. Okay, you're welcome. You're welcome. Oh, The plug in 1 for theta to get pi over 4. You're right. Not theta. Not theta. Here. So what's it like equation? So this one is inverse tangent of 1. What is the answer? We don't know. It's right. We don't know. This case is you can use anything. It doesn't matter. Theta. You don't like theta. You can use value of x. It doesn't matter. You can use definition. The inverse of y equal to x is given. You can change it to the y equals f of x form. This is like a reason. Change it to the 1 equals f of x is tangent of x. Tangent of x equal to 1. What is x? Only angle pi over 4. This is like a reason. The angle pi over 4. It's good? That's right. You can plug in 1 for theta, right? To get pi over 4. You're right. Yes. So your question is right. Yes. Do you have more questions? So could you write your question on the chatting board? So if you don't have any more question, just to the leave live session. I'm just only waiting for your questions. So just write your questions.